Let's look at this problem. The first of two consecutive lenses has a focal length f1 is 4 centimeters. The second lens has focal length f2 is negative 3 centimeters. An object is placed 5 centimeters in front of the first lens, and the final image of the object is 2 centimeters to the left of the lens on the right. What is the separation between the lenses? Well, let's draw a picture first so that we can figure out what in the world this problem is asking us. So we have two lenses, and the first thing I notice is that the first lens has a positive focal length, so it's converging. The second lens has a negative focal length, so it's diverging. So I have a converging lens and a diverging lens, and I know their focal lengths. Now, we are also told that an object is placed 5 centimeters in front of the first lens. So this here is 5 centimeters. And then we're told that the image of the object is 2 centimeters to the left of the lens on the right. So 2 centimeters to the left, the final image is going to be somewhere here. This is 2 centimeters. So let's write down our knowns and unknowns and pay attention to the signs. So we know that f1 is 4 centimeters, f2 is negative 3 centimeters. We know that DO1 is positive 5 centimeters, and the final image is 2 centimeters to the left. So DI2 is negative 2 centimeters. Remember that with lenses, we expect light to come from the left and form an image on the right. That means that we're going to assume that positive distances are on the left of the lens and positive distances for images should be on the right of the lens. Well, for this one, we're told that the image is 2 centimeters to the left, so that makes the image distance negative. Now, the thing that we're asked to find is the separation between the two lenses. Let's call that x. So our unknown is the distance x. All right, well, let's work with what we know. So we know that for the first lens, 1 over f1 is 1 over DO1 plus 1 over DI1. The only thing that we don't know in this equation is DI1. We know the focal length is 4 centimeters. We know the object distance is 5 centimeters, so we can find the location of the image through the first lens. So DI1 then is 1 over f1 minus 1 over DO1 to the negative 1. So that is 1 over 4 minus 1 over 5 to the negative 1. And if we do the math, we end up with 20 centimeters. So we know that the image distance, I'll make that a different color. We know that the image distance DI1 is 20 centimeters. So this is where the image to the first lens will be formed. Now let's work backwards and look at the second lens, see what that is doing. So for the second lens, I have 1 over f2 is 1 over DO2 plus 1 over DI2. So in this equation, I know the focal length and I know the final image. I know where the final image is located. I can solve for DO2, and DO2 will be this distance. This is DO2. So 1 over DO2 is 1 over f2 minus 1 over DI2, which means that DO2 is 1 over f2 minus 1 over DI2 to the negative 1. So that is 1 over focal length 2 is negative 3 minus 1 over DI2, which is negative 2, to the negative 1. And if we plug in the numbers, we end up with 6 centimeters. So again, let's look at the things that we know. We found the image distance with the first lens to be 20 centimeters, but the object distance for the second lens is 6 centimeters. So if I add these two values together, I end up with x. So then x is di1 plus do2, and that is 20 plus 6, or 26 centimeters. Now, we didn't look at pluses and minuses for the second lens, so let's do that now. So I had the focal length to be negative, and the object distance is what I was solving for. I knew that the image distance is negative because it was going to be formed to the left of the second lens. So when I solved then for DO2, I ended up with a positive number. The positive number tells me that the object starts to the left of the second lens because light started from the left side. So DO2 being positive here makes sense, and it's consistent with what we had for the first lens. So we had an object starting here, it forms an image there which becomes the object for the second lens, forming an image at this location. And then when we add the two distances we solved for, we end up with a separation between the lenses of 26 centimeters.